Hello everyone. This module is to explain about artificial neural network. And particularly in this module, I'm going to start with the concept of the neural network. Okay, actually it comes from human neural network. So there's a neurons and synapses, um, and looks like there's a node, the input variable, which holds the input variables. They communicate each other, and finally there will be an output. The idea here is that we know the output, which is simply a supervised learning, the value. This is what we know. This is the input. So given inputs and output, we want to train in this module. The, the computation in between input and output consists of the aggregation of interaction and activation functions. So this aggregation aggregates the weighted value from the input, and then we pass it through an activation function to clean up the values, whether it is between two extreme values, for example, true or false. There is some function. If it is above a certain criteria, then it'll be some values. So it'll be, for example, in this circle, there is a red curve. Depending upon the value x, it can be immediately go up to the upper bound. If x is below certain criteria, it goes down to the lower bound. So this activation function that we are going to use in this case is a sigmoid. This sigmoid function can discern the values between true and false. All right. So that is the basic idea. So for example, given data, let's say IP, source IP and destination port number. If source IP is in blacklist and destination port is 22, then it is attackable. 22 is a secure shell port, right? And although it is in the source IP is in the blacklist, destination port number is 8080, for example, web service port number, then it's not necessarily attackable. Okay, so we have this kind of trained data sets, training data sets. So with that training data sets, we train this model, which is artificial neural network, and then what we could have is finally this weight W1 and W2 will be well trained. Therefore, depending upon W1 and W2, we can quickly see, oh, that is attackable or that is non-attackable. That type of conclusion can be made quickly after we train with the training data sets as many times as we could. Usually, this artificial neural network trained millions of iterations or tens of millions or even billions. From this simple example, we trained tens of million times, then W1 and W2 or weights can be converged. So that iteration continues until we know for sure the weights can be well trained, which means converged. Okay, if we have converged weights, then that is the points that we can stop the training phase. All right, so we can implement that in this Python language. This is very simple ones. So let's say the x11, x12, then This is in blacklist. This is a blacklist. This is the port number 22. This is port number 88. Then training is maybe 1 and 2, 1 and 0. But right now, this explains how we can get the output values. Okay, so if we run this, then output here, y1 is 0.8, y2 is 0.6. This is close to 1. This is close to 0. So as we iterate this as many as we could, then this will be hopefully 1.999. This will be 1.00 some. If we have that type of weight, I mean, to make this trained output, then we know W. W is not yet trained, right? The way that we can train weights is we need to see when we obtain the value here, this value and that supervised learning values are not the same from the beginning, right? Of course. So this is a computation, and then trained value is 1 and 0. So there's some gap. So we call that error. So that error needs to be computed continually, and then that should be go back to the original weights to adjust. So W1 and W2 will be adjusted continually. So this is a simple computation. We didn't do anything yet. We simply do forward feed forwarding process. We could do this in an array because we don't want to do the input variables. If we have 4 variables, then it's simple. But if we have hundreds of million variables, and then weights also of hundreds of millions, then this computation is a billion times. We do not want it, right? So that we need to make an array. So in order to do that, we need to import numpy. This is sigmoid functions. We can create the input variables, input values, using that numpy. There is an array constructor. We can construct array of x and array of y, and then also weights. We can put initially any number, or we can randomly generate. But based upon this trained supervised learning output, this will be updated. So the computation from this x and w, and therefore the output will be closer to the supervised, given output. Okay. In order to that, we need to dot operation. So we have a product x and w, very similar to we have x11 times w1 plus x21 times w2. This is aggregation of the interaction. That is the dot operation. Then, and after that, we pass it to sigmoid, the activation function. Okay. So if we do this, then z1 and z2, z1 is and z1, and therefore we have after sigmoid, this is output. So output is 0.8 from the first set here, and then from the second set, we have here 0.6. All right. This explains to you basic the concept of the artificial neural network. Right now, we didn't do any adjustment of weights. That can be done by back propagations. Okay, it'll come